Good morning, dear participants. You are welcome to this lecture, which is part of the Research Methodology in Medicine workshop. I am Dr. Ikekezie Oyenike, Deputy Registrar, Senate and Governing Board Affairs of the National Postgraduate Medical College of Nigeria. Today we'll be talking about correlation and regression. We'll be looking at its use in statistical analysis. I hope you all had time to go through this material before today so that it will be easy for you to follow me. What is correlation? Let's break down the English. Correlation. Correlation. So when we're talking about relationship, it means there is more than one variable involved. If we have two variables and the value of one has no relationship to the value of the other, these variables are said to be independent. However, if the value of one is related to the value of the other, has a bearing on the value of the other, either when one is high, the other is also high, or when one is high, the other variable is low, then we say these two variables are correlated because there's a relationship between them. Correlation analysis, therefore, is the study of the association between two variables. We are going to explore linear relationships. We can have more than linear. We can have non-linear relationships. But for the purpose of most of the work we will do, which would involve one biological variable or the other, we will be looking at linear correlation. Now, correlation can be direct, correlation can be indirect. If Y variable increases as X variable increases, then the relationship between them is described as a direct or positive correlation. We can also have an indirect or negative correlation. If variable Y decreases as variable X increases, then we have an indirect or negative correlation. For example, what relationship exists between CD4 count and viral load? I'm sure we all know that as CD4 count increases, viral load reduces. Therefore, this is an example of indirect or negative correlation. A scatter diagram. We're all familiar with it. Don't worry, I'm going to show you a picture shortly. It's an exploratory tool which gives us the first impression about the relationship that exists between two variables. If there is a linear relationship or if there's no linear relationship. When we're talking about correlation, it is usual to put the dependence or outcome or experimental variable on the y-axis, which is the vertical axis. and we put the independent or observed variable along the horizontal axis, which is our variable x. Now, I don't want us to cram dependent, outcome, experimental variable versus independent or observed variable. Let's break it down so that we understand what they mean. Now, a variable is said to be independent, is said to be dependent if its value depends on the value of another variable. Simple. Let me even be sure you understand what a variable is. A variable is any entity that can assume different quantum. It changes. It's not static for everybody. For example, weight. Human beings don't have the same weight. Height. We don't have the same height. So these are variables because their quantum, their magnitude changes. It's not static. So like I said, dependent variable means its value depends, has a bearing on the value of another variable. This is usually also known as the outcome variable because its value is as a result of something else, is an outcome of a process. And it is also the experimental variable because it is usually the variable we are interested in. If I have age and blood pressure, these are two variables. Age changes for everybody, blood pressure changes for everybody. So they are both variables because their magnitude changes. Between age and blood pressure, which is the dependent variable? Of course, blood pressure, because it depends on the age. We know as we increase in age, from a certain level, blood pressure increases. Even when we're talking about normal blood pressure ranges, it still increases with age. So blood pressure as a variable is dependent on age. Our blood pressure is also the outcome of our aging process. And usually in studies, the blood pressure, when you compare that to the age, will be the experimental variable. That is what we will be interested in. We would want to know the profile of blood pressure for the group we're looking at and whatever else is in our objective. Now, what is independent or observed variable? Is independent. It exists like that. It is what it is. We just observe it and report it. Between age and blood pressure again, age is obviously the observed variable. It is independent. The age does not depend on the blood pressure. We observe what the age is. Maybe we ask for your date of birth. So it is observed. So when talking about correlation, it is usual but not compulsory that on the vertical axis, we have the dependent variable y, and on the horizontal axis, we have the independent variable x. I said it is usual, but by the time we go on to regression, it is expected. So let us look at scatter diagram. These are three scatter diagrams representing First, direct or positive correlation. Secondly, indirect or negative correlation. And thirdly, no linear correlation. Because no matter how much you try, there is no straight line that is going to connect these points. So no linear correlation. Another type of correlation may exist. So let's break it down one by one.